Good morning students. Today we will see de Broglie's wavelength only for electrons, associated with electrons and some of the properties of matter waves. Last class we have seen de Broglie's wavelength for photons. For photons, de Broglie's wavelength is lambda is equal to h by mc. Next, for electrons we got for electrons and all other material particles we got lambda is equal to h by mv. In terms of kinetic energy we got lambda is equal to h by square root of 2mv. Now we are going to calculate de Broglie's wavelength associated with electrons, only with electrons. Now let us consider an electron which is having mass m and it is having charge E, which is accelerated by a potential v volts from rest. So actually electron is at rest. We are considering electron is at rest. If we give certain voltage v volts, then it is moving with velocity v. So moving particle always have kinetic energy. So kinetic energy of electron is half mv square, mass into velocity square, which is equal to kinetic energy in terms of potential. Kinetic energy in terms of potential can be written as qv. Q is the charge, but here we have taken charge as E. So EV. So if I take this to this side, I'll get 2EV. Next, this m also this side, I'll get 2EV by m. So V square is equal to 2EV by m. So I can write V is equal to square root of 2EV by m. This is equation number 1. This V represents velocity. This capital V represents potential, voltage. Now we know de Broglie's wavelength lambda is equal to h by mv. This is equation number 2. So from equation 1 we have V. So substitute 2 in 1. So if I substitute 2 in 1, we'll get as, see here. So lambda is equal to h by m square root of 2ev by m. So m by root m get cancelled and you'll get root m. So h by square root of 2evm. Now what is h? Here what is h? H is Planck's constant. Its value is 6.625 into 10 power minus 34 joule into second. Next, what is E? Charge of electron. Charge of electron is 1.602 into 10 power minus 19 coulombs. M is mass of electron. Mass of electron is 9.1 into 10 power minus 31 kgs. So students has to remember these quantities so that they will not give in the problem. You need to remember. So H, E, M. These values if I substitute in the above equation. What is the above equation? Lambda is equal to h by square root of 2evm. So I will substitute all these values. So 6.625 into 10 power minus 34 divided by square root of 2 into charge of electron 1.602 into 10 power minus 19 into 9.1 in 10 power minus 31 into voltage. So if we calculate, so take out the calculators and calculate and check whether you are getting this answer or not. So lambda is equal to 12.26 into 10 power minus 10 by root v meters. So 10 power minus 10 meters is nothing but 1 angstrom. So 12.26 by root v angstroms. So this is the de Broglie's wavelength only for electrons. Only for electrons, de Broglie's wavelength is lambda is equal to 12.26 by root v. So this is about de Broglie's wavelength associated only with electrons. Now if we move with next topic, if we move with properties of matter waves. So what are the properties of matter waves? Before going to properties of matter waves, what is a matter wave? So we know that moving particle is always having wave nature, that we call it as matter wave. So for this matter wave we will give the properties. So de Broglie's wavelength for the moving particle is lambda is equal to h by mv. So here lambda is equal to h by mv. M. If mass of the particle is less, what about wavelength? It is more. So lighter the particle, greater is the wavelength associated with it. Next, if velocity is less, again greater the wavelength. So smaller the velocity of the particle, greater is the wavelength associated with it. Next, see here, these matter waves are not electromagnetic waves. Electromagnetic waves means they should have charge. But matter waves means it can be a proton, it can be a neutron, it can be an electron. Electron is having charge, proton is having charge, but neutron doesn't have charge. But matter wave is associated with it. That's why these are not electromagnetic waves. Because whether the particle is charged or not, matter wave is associated with it. Now, so see here, for velocity v is equal to 0. In this expression, if velocity becomes 0, then wavelength becomes infinity. What does this mean? What does this mean? If particle is not moving, there is no wavelength. If the particle is moving, then only we have wavelength. Means moving particle will be having wave nature. Next, see here matter waves are independent of charges because neutron doesn't have charge. So there doesn't depends on charge. Next, phase velocity or wave velocity of matter wave is greater than velocity of light. Means see here, when the particle is moving like a wave, when the particle is in a wave, so its velocity will be more than the velocity of light. Next, no single phenomenon exhibits both particle and wave nature simultaneously. Means in single experiment I cannot prove both particle and wave nature at the same time. Next, when the particle is moving like a wave, can I give exact position? No, exact position cannot be given. Exact location of the particle cannot be given. For example, in the break time, when you are roaming, in the break time, can I give exact position of you? No, you may be in the canteen, you may be roaming in the ground. So I cannot give exact location of you. So the wave nature of particle introduces an uncertainty in the location of the particle. It becomes uncertain. The location is uncertain. So this leads to Heisenberg's uncertainty principle. So this is about properties of matter waves. So today we have discussed about de Broglie's wavelength for electrons and properties of matter waves. Thank you.